Modern medicine stands on the brink of a revolution. This revolution is driven by the convergence of biology, mathematics, and technology. Precision is paramount in this new era. Gone are the days of one-size-fits-all treatments. Today, we strive to tailor therapies to individual patients. This is where the power of mathematics shines. Ibogaine, a naturally occurring alkaloid, exemplifies this shift toward precision. It holds immense promise for treating addiction and mental health disorders. However, its potency necessitates meticulous dosing. Too little, and the therapeutic potential remains untapped. Too much, and adverse effects may arise. This is where mathematical tools become indispensable. Integration helps us understand how much of the drug actually reaches the bloodstream. Differential equations allow us to model how the drug's concentration changes over time, depending on individual factors. Matrix theory provides a framework for optimizing treatment regimens, and engineering statistics enable us to analyze data from clinical trials, ensuring the safety and efficacy of this powerful substance. The marriage of mathematics and medicine is not new. What is new is the sheer complexity of the problems we can now tackle. With Ibogaine, we are on the cusp of transforming the lives of millions struggling with addiction. Mathematics is the key to unlocking its full potential. By embracing these powerful tools, we can usher in a new era of hope and healing.
Imagine administering a drug, only to discover that only a fraction of it actually reaches the intended target in the body. This is the challenge of bioavailability, the proportion of a drug that enters the bloodstream and exerts its effects. It's a crucial factor in determining the right dosage for any medication, especially one as potent as Ibogaine. This is where the elegance of calculus, specifically integration, comes into play. Integration allows us to calculate the area under the curve of a graph representing drug concentration in the blood over time. This area represents the total exposure of the body to the drug. Think of it like measuring the amount of water flowing through a pipe over a period of time. The flow rate might fluctuate, but integration allows us to calculate the total volume of water delivered. Similarly, integration helps us determine the total amount of Ibogaine absorbed by the body. By understanding bioavailability, we can refine dosage regimens for maximum effectiveness. This ensures that patients receive the therapeutic dose they need, while minimizing the risk of side effects. In the realm of Ibogaine treatment, where precision is paramount, integration provides a vital tool for optimizing therapeutic outcomes.
Each individual is unique, with a different physiological makeup, metabolism, and medical history. This uniqueness extends to how we respond to medications. A dose that works wonders for one person might be ineffective or even harmful for another. This is where differential equations come into play, allowing us to model and predict how drug concentrations change within an individual over time. These equations capture the dynamic interplay of various factors influencing drug behavior within the body. Absorption, distribution, metabolism, and excretion. All these processes are factored into the equation, creating a personalized model of drug kinetics. Consider a patient struggling with both addiction and depression. Their dosage regimen for Ibogaine would need to account for both conditions. Differential equations allow us to simulate the effects of different dosages, taking into account how these conditions might influence drug metabolism and efficacy. This personalized approach to dosage is a cornerstone of precision medicine. By understanding the individual patient's response to medication, we can optimize treatment strategies, maximizing therapeutic benefits while minimizing potential risks. Differential equations provide the mathematical framework for this personalized approach, paving the way for safer and more effective treatments.
Section 4. Matrix Theory. Decoding the complexity of treatment. Treating complex conditions often requires a multifaceted approach. Multiple medications, therapies, and interventions may be employed simultaneously. This intricate web of treatments can be difficult to manage and optimize. This is where matrix theory, a powerful mathematical tool, comes into play. Matrices, with their rows and columns of numbers, provide a structured way to represent complex relationships. In the context of Ibogaine treatment, matrices can capture the interactions between different medications, their dosages, and their effects on various symptoms. Imagine a matrix where each row represents a different medication used in conjunction with Ibogaine. Each column could represent a specific symptom being addressed. The numbers within the matrix would then represent the influence of each medication on each symptom, allowing clinicians to visualize and analyze the complex interplay of treatments. By manipulating these matrices, we can optimize treatment regimens. We can identify potential drug interactions, adjust dosages to maximize efficacy, and minimize the risk of adverse effects. This mathematical framework provides a powerful tool for navigating the complexity of treatment, leading to better outcomes for patients with multifaceted conditions.
Section 5. Engineering Statistics. Optimizing outcomes through data analysis. In the quest for effective treatments, data is king. Clinical trials generate vast amounts of data on patient responses, treatment outcomes, and potential side effects. Making sense of this data deluge is crucial for refining treatment protocols and ensuring patient safety. This is where engineering statistics plays a vital role. Statistical methods allow us to analyze data from clinical trials, identifying trends, patterns, and correlations. We can determine the effective dosage range for different patient populations, taking into account factors like age, gender, and medical history. Imagine analyzing data from a clinical trial on Ibogaine treatment for opioid addiction. Statistical analysis can reveal the optimal dosage range for different subpopulations, such as those with a history of trauma or co-occurring mental health conditions. This data-driven approach allows for tailored treatment strategies, maximizing the chances of successful outcomes. Furthermore, statistical modeling helps us understand the variability in patient responses. Not everyone responds to treatment in the same way. By identifying factors that contribute to these variations, we can personalize treatment plans and improve outcomes for individuals. Engineering statistics provides the tools to extract meaningful insights from data, guiding the development of safer and more effective treatments.
Section 6. The future of healing technology-driven precision in healthcare. The convergence of mathematics, technology, and medicine is ushering in a new era of healthcare. Precision is no longer an aspiration but an achievable goal. In the realm of Ibogaine treatment, this translates to safer, more effective, and personalized approaches to addiction and mental health care. Imagine a future where algorithms, informed by vast datasets and powered by artificial intelligence, assist clinicians in determining the optimal Ibogaine dosage for each patient. Wearable sensors could track vital signs and medication adherence, providing real-time feedback and adjustments to treatment plans. The potential impact of these advancements is profound. We could see a dramatic increase in the success rates for addiction recovery and a reduction in the devastating consequences of mental health disorders. Precision medicine holds the key to unlocking a future where treatment is tailored to the individual, maximizing healing and minimizing suffering. This is not just a future possibility, it's a future we are actively creating. By embracing the power of mathematics and technology, we are paving the way for a healthcare revolution, one that prioritizes the individual and empowers us all to live healthier, more fulfilling lives.